All right, welcome everyone to a new series of burst sessions. This series of 6 will focus on computational fluency in grades kindergarten through grade 5. There'll be another series focusing on grades 6 to 9 as well in computational fluency. My name is Janice Nowakowski, and I am the district teacher consultant for the Richmond School District in K-12 mathematics and numeracy. So what is computational fluency? That is the focus of this first burst session. It is a big idea. It's one strand in our mathematics curriculum, and we use that term a lot. So I thought we'd spend some time really looking at what does that mean. So computation, the computational part of computational fluency, is the calculation with numbers using the operations. So addition, subtraction, multiplication, and division. And according to the National Council of Teachers of Mathematics in a publication from 2000, they define computational fluency as having efficient, flexible, and accurate methods for computing. And the NCTM is the organization that is drawn upon, the research and the evidence, and mathematics education researchers and educators come together to create these sort of policy statements, drawing upon current research. A little bit more broadly, the student that has computational fluency can get an answer to a question, not just quickly. Quickly isn't really a word that we use with computational fluency, but efficiently. So they are not doing multiple steps in a sort of a convoluted way. They look at a question and they're like, oh, I could do this, or I could do this, I could do this. They choose an approach and they get an accurate answer. And they're also able to explain how they got their answer, what strategy they chose and why. And so I think that that's an important component of this fluency is students choose a strategy based on the numbers, based on the operation, and based on what they understand. So it's not something that they have necessarily memorized or have formally been taught. They're strategies that they have pulled together based on their knowledge of the numbers that they're working with. So they're drawing upon place value, or they're drawing upon their understanding of the relationship between addition and multiplication and that knowledge, and then they're able to compute in more than one way. And that's another component of fluency, is being able to have multiple strategies to draw upon is an aspect of being fluent. And so you can be flexible. Well, I'm going to use this strategy with these numbers because, but with these numbers, I'm going to use this strategy because, and again, being able to explain those choices. So I wanted you to think a little bit about when else do we talk about fluency besides computational fluency in math. So we often talk about a fluent reader, and just make a picture in your mind. What is a fluent reader to you? What are they able to do? What does that sound like? What does that look like? So to me, a fluent reader is someone who is able to read the text. They're able to read it with understanding. They're not just reading the words. They can tell you what it's about, what they've read about, and they know when to pause, with the punctuation and place emphasis on different words, etc. Just like a language learner, fluent in English or French or Spanish or Japanese or Mandarin. What does it mean to be fluent in a language? Again, you have a vast vocabulary. You draw upon specific language that makes sense for whatever it is that you're trying to communicate, whether you're expressing the language or whether you're receiving the language. You're fluent in both forms. You also, when you're using expressive language, you know when to emphasize certain words, and you have expression. That's part of being fluent in a language, also being fluent as a reader. So thinking about how that connects to mathematics and computational fluency, meaning as being important, right? Understanding what it is that we're doing, ability to transfer and apply your knowledge into new situations or contexts and make meaning of it. And that being fluent is also connected to who you are as a person. It's personal, how you make meaning of something, and the strategies and the knowledge that you bring to different questions. So when we look at the BC curriculum and where computational fluency lives, it's in the big ideas, and it's also in the content and in the competencies. So it's, when you look at the 5 big ideas across each grade level, it's the second one in. So in most curriculum, math curricula around the world, there's 4 strands. There's number concepts and operations, there's pattern and algebra, there's geometry and measurement, there's data and probability or statistics. In our revised curriculum from 2016, we have separated out, there's number concepts and number sense, And then there's computational fluency, which is that fluency piece along with the operations. So again, when you hover over that site, this is for grade 3 as an example, that blue part, this pops up and we have the meta big idea for computational fluency, which is that it develops from a strong sense of number. That's the same from kindergarten to grade 9. And then you have some sample questions in which to investigate and explore what it means to be fluent with computation. So that's the big ideas, and that's where it lives. And then it also, well, here's all the big ideas from K to 5. So you can see how it progresses from kindergarten to grade 5. Grade 1, kindergarten, we're not doing formal adding and subtracting, but we are composing and decomposing numbers to 10 and really understanding 5 and 10 as benchmark numbers. So that's really essential for fluency as we move up the grades and working on our facts within 20 and then using adding and subtracting with larger numbers as well. And then you can see again from grade 1, the concept of addition and subtraction is introduced, and then strategies are introduced, and then it progresses up to grade 5, where we're looking at numbers with larger multi-digit numbers and operations with those. When we look at curricular competency standards, now these are essentially the same from kindergarten to grade 9, but these are some of the ones for K to 5 that really focus on or are connected to computational fluency. So using reasoning, estimating is a very big part of number sense and computational fluency. Using mental math strategies, huge part of computational fluency. Visualizing, so making pictures in your head, using pictures like 10 frames or number lines to help us visualize the mathematics. Communicating our thinking and sharing how we did that. Very big part of computational fluency, explaining and justifying our ideas and decisions, and then connecting mathematical concepts to each other, because especially as students are in grade 2, 3, 4, and 5, we want them making those connections in terms of how can we use addition to help us think about subtraction, and how can we use multiplication to help us think about division, and how can we use addition to help us think about multiplication, etc. So making those connections across concepts is a student who is fluent with computation. And then we have the content standards. And these, of course, increase as the grades go on, as you can see. So again, in kindergarten, it's really focusing on decomposing and composing those numbers to 10. And then in grade 1, addition and subtraction and the symbols associated with those are formally introduced. And then in grade 2, the strategies are introduced. And then you're also applying what you've learned about addition and subtraction to 20 to think about as addition and subtraction to 100. So double-digit numbers. And then in grade 3, addition and subtraction with 3-digit numbers, as well as introducing multiplication and division. So those operations start to addition and subtraction continue all the way through grade 7, and multiplication and division are introduced in grade 3 and continue to develop. Now, what an interesting thing that happened when the curriculum was being rewritten, and we looked at addition and subtraction facts and multiplication and division facts, we used some new language, and you can see it here. So for example, grade 4, addition and subtraction facts to 20, it says developing computational fluency. Here it says emerging in grade 3, and it says extending in grade 5. Well, this was long before we used the proficiency scale. But as writers on the curriculum team, we were trying to find a language to sort of explain that this doesn't all happen in one year. Kids learn their addition and subtraction facts. It happens over multiple years. And so in the current curriculum, it's 5 years that students are developing their addition and subtraction facts to 20, and 5 years for their multiplication and division facts. So grade 1, addition and subtraction, the concept is introduced and the process is introduced. In grade 2, the strategies are introduced, like making 10 and using known facts and doubles and related doubles, etc. Addition and subtraction facts to 20 emerging. So again, by grade 3 is when we expect that students will be able to recall some of their basic addition facts to 20, especially with the smaller numbers or the 5s or the 10s, and building on 10 as an example. So it's, again, working within 20. It's not expected that they've memorized, but that they've had enough experiences that they can recall the answers to those facts because they've done those visualization strategies, because you've done number talks, because you've played math games, etc. And they can also explain why they got the answer that they did. And then again, developing in grade 4. And so that's, again, having fluency with most, being able to recall most of the addition and subtraction facts. And then grade 5 is really extending. And that's when, they're able to take like a fact. If they know 7 plus 8 is 15, they can transfer that to, adding 700 and 800 or 750 and 862. But they use that 700 and 800 to know that that's 1500 as a starting point for decomposing. And they're using their known facts and connecting them to larger numbers. And then also with decimal numbers in grade 4 and 5 as well for addition and subtraction. So this is a visual of that continuum so that you can see, that we're responsible, as an elementary, system, K to 7, for all of us are responsible to help children learn their addition and subtraction facts and their multiplication and division facts, starting in grade 3 through grade 7. We really are doing students a disservice if they leave our elementary system not being fluent with their basic addition, subtraction, multiplication, and division facts. So part of this whole series is looking at this and how can we support our students with this? And so one resource, if you're not familiar yet, is our Numeracy Foundations frameworks that are part of our district strategic plan. So there's a K-2 framework, there's a grades 3 to 5 framework, a grade 6 and 7 framework, and a grade 8 and 9 framework. And we're working on the grade 10 to 12 framework now. They're currently hosted on the portal, but there will be a new platform that they will be hosted on, I think sometime in this spring or summer. It's 2024. And so again, all these, when you go to the portal through the Learn 38 and you click on the tile that says K-2 Numeracy Foundations, for example, all of these blocks or tiles are clickable. So if I clicked on computational fluency, a PDF would come up that has hot links in it that will take you to different websites. You can also print it as a PDF. And lots of teachers I know like to do that. So this is what it looks like for K-2. It identifies what computational fluency is. It lets you know what the key concepts for that K-2 range are. Some things to consider when you're designing your week plan or your lesson plans. And there's an example of a week plan for you with 5 different lesson types. There's a link to instructional routine videos like number talks or number talk images that are connected to computational fluency, and some suggested instructional strategies like number talks, soft start explorations with number focused materials, math workshop, math games, etc. The second page has materials that support computational fluency at K-2, a couple instructional ideas like math stories and math games, and then ways to assess computational fluency. And those links take you to 3 district resources, the proficiency indicators. So what is proficient for each of those learning standards, the computational fluency assessment questions for each grade level, and then the K-2 early numeracy assessment tool. Similarly, we have one for grades 3 to 5. So if you go to the 3 to 5 framework and you click on computational fluency, again, it's laid out in the exact same way, but it has the key concepts focusing on 3 to 5, things to consider, lesson plans and week plans, instructional strategies, materials, instructional ideas like problem posing and math games, and then the same assessment tools, except the assessment tool is the grade 3 to 5 assessment tool, which was created by teachers here in Richmond. All right. So as we come to this conclusion of this very short burst session, introducing this big concept of what is computational fluency, I would like you to sort of consider these questions. What do your students need to move towards developing computational fluency? So what kinds of background knowledge and understanding of numbers do they need? What are some different ways to develop computational fluency? And then how can computational fluency be assessed? What are you doing now, and what might you do in the future? And we will be addressing all those questions in the next 5 burst sessions of this K-5 computational fluency series. Thank you for joining me.